Welcome to our first mathematics practice questions of this course. In this video, we will dive into practice questions involving analytic geometry and trigonometry. Ensure you have the FE Handbook open and reference its material throughout this lecture, as you must become familiar with it before exam time. As a supplement to this course, I have created full-length practice exams and other topic-specific practice questions that can be accessed through the link on screen or in the description. These practice exams are the best way to prepare yourself for taking the actual FE exam. Follow the timing requirements to mimic testing conditions and review the detailed solutions to learn from your mistakes. Moving on, let's get started with some mathematics practice questions. Practice question 1. Which of the following equations represents an ellipse? Take a moment to pause the video and solve this problem yourself before moving on to the solution. We start by recognizing the general form we're looking for. For an ellipse, we want the equation to be in the form a times x squared plus b times y squared equals c, where a and b are not equal, but both positive. With that in mind, we move on to check the answer choices. What we're doing here is comparing each given equation against the pattern we just talked about. We eliminate the first choice because it represents a circle. A and b are equal, which means it doesn't meet the condition for an ellipse. Next, the second choice fits the general form we're looking for. The coefficients of x squared and y squared are positive but not equal, and there's no xy cross term, which is a strong indicator that this is an ellipse. The third option is a hyperbola, which we can tell because one of the squared terms has a negative coefficient. And finally, the last one has a mixed xy term, which tells us the conic is rotated, which is not what we are looking for here. So after checking each option carefully, we can conclude that the second choice, option B, is the one that correctly matches the structure of an ellipse equation. Practice question 2. What is the eccentricity of the hyperbola given by the equation x squared over 36 minus y squared over 16 equals 1? We start by identifying the type of conic section. The equation shown matches the standard form of a hyperbola. From this form, we can directly identify the values of a squared and b squared. Next, we apply the eccentricity formula for a hyperbola. We substitute the known values into the formula and simplify. This gives us the square root of 13 divided by 3. At this point, we approximate to get 3.605. Dividing that by 3 gives us about 1.2. Finally, we compare our results to the available answer choices and find the closest match. 1.2 is the same as 6 over 5. Therefore, the correct answer is choice C. Practice question 3. In triangle ABC, side A is equal to 15 centimeters, side B is equal to 30 centimeters, and angle A is equal to 35 degrees. What is the measure of angle B? Round to the nearest degree. In step 1, we start by recalling the law of sines, which tells us that the ratio of the sine of an angle to the length of the side opposite that angle is constant across a triangle. In step 2, we plug in the known values for the triangle. Next, we solve for the sine of the unknown angle. We isolate the sine of angle B on one side of the equation and evaluate the right-hand side numerically. This gives us a decimal value for sine of B. Then, we take the inverse sine, which gives us approximately 49.9 degrees. This rounds to 50 degrees. Therefore, the final answer matches answer choice B. Practice question 4. Simplify the following expression. We start by recognizing that the expression we're simplifying matches a well-known set of sum-to-product identities. Specifically, the difference between cosines and the sum of sines identities. Using these identities, we rewrite both the numerator and the denominator. Now, because both the numerator and denominator share the same sine term and the constant factor of 2, we can cancel them out. This leaves us with a negative sine of alpha minus beta over 2 over the cosine of alpha minus beta over 2. At this point, we're left with a basic trigonometric ratio, sine over cosine, which simplifies directly to tangent. Since the sine term was negative, the final result is the negative tangent. So, the final answer is option D. Practice question 5. Which of the following is always true for any triangle? The sum of any two sides is less than the third side. The sum of the measures of any two angles is greater than the third angle. The area of a triangle is greater than the length of its longest side. Or the medians of a triangle always meet at a single point. First, we recall an important property about medians in any triangle. The three medians of a triangle, that is, the line segments from each vertex to the midpoint of the opposite side, always meet at exactly one point. This point is called the centroid. It does not matter if the triangle is acute, obtuse, or right. The medians will always intersect at a single point inside the triangle. Now, let's check each answer choice carefully to eliminate the false ones. Option A says the sum of any two sides is less than the third side. That is false. In fact, by the triangle inequality theorem, the sum of any two sides must be greater than the third side, not less. Option B claims that the sum of the measures of any two angles is greater than the third angle. This is false as well because in some obtuse triangles, the largest angle can be greater than the sum of the two smaller angles. Option C suggests that the area of a triangle is greater than the length of its longest side. This is not necessarily true. The area depends on both side lengths and angle measures, and in very narrow or flattened triangles, the longest side can actually be larger than the area. Option D states that the medians of a triangle always meet at a single point. This is true. As we recalled at the beginning, this is the centroid property of triangles. Therefore, the correct answer is option D. Practice question 6. What is the area of a sector with radius r equal to 8 centimeters and angle theta equal to 150 degrees? We start by using the formula for the area of a sector, which says the area is equal to 1/2 times the arc length times the radius. Since the arc length is the product of the radius and the angle in radians, we first need to convert the angle from degrees to radians. We do this by multiplying the degree measure by pi over 180. We find that the angle in radians is 5 pi over 6. When multiplied by the radius, we end up getting an arc length of approximately 20.93 centimeters. Plugging everything back into the area formula and simplifying, we get a final area of about 83.72 centimeters squared. Looking at the options, we can match our answer to option D. Practice question 7. What is the volume of a cone with height h equals 9 centimeters and base radius r equals 3 centimeters? Assume pi to be 3.14 exactly for this question. We begin with the standard formula for the volume of a cone. Next, we plug in the given values. Our radius is 3 centimeters and our height is 9 centimeters. Now we simplify, which ends up giving us approximately 84.78. So the correct answer is choice A. Practice question 8. In a right triangle, one leg is 7 units shorter than the other. If the hypotenuse is 17 units, what is the length of the shorter leg? To solve this right triangle problem, we start by recalling the Pythagorean theorem, which relates the lengths of the sides of a right triangle. We're told the hypotenuse is 17 units. One leg is 7 units shorter than the other. So, we define the shorter leg as x, and the longer leg becomes x plus 7. We then plug these into the Pythagorean theorem. Expanding the squared term and combining like terms gives us a quadratic equation. From there, we simplify the expression by combining like terms again, and then divide every term by 2 to make the numbers easier to work with. We now have a standard quadratic equation that we can factor. Factoring gives us 2 potential solutions for x, one positive and one negative. Since we're talking about a physical length, we discard the negative result. The positive solution is 8, which represents the length of the shorter leg. So, the final answer is 8 units or choice B. Practice question 9. Line L1 passes through the points A and B. Line L2 is perpendicular to L1 and passes through the point C. What is the equation of line L2 in slope-intercept form? First, we start by finding the slope of L1, which passes through two given points. To do this, we use the slope formula, change in y over change in x. Once we calculate the slope, we can understand how the line is oriented. Next, we apply the slope rule for perpendicular lines. In coordinate geometry, two lines are perpendicular if their slopes are negative reciprocals of each other. In our case, we simply take the reciprocal of the slope we found earlier and change its sign to find the slope of the new line we're looking for. This gives us a slope of -1. Finally, we use the point-slope form of a line to build the equation of the new line. Since we now know the slope of the perpendicular line and the point it passes through, we plug both into the point-slope formula. Once we simplify that expression, we rearrange it into slope-intercept form, which is the format we're asked to provide in the question. The final result is y equals -x plus 3. This corresponds to option A. Practice question 10. Let points A, B, and C be in plane. Let line L1 pass through points A and B, and line L2 pass through points A and C. Let alpha be the angle between L1 and L2, and let d be the perpendicular distance from point B to line L2. What is the value of d times the tangent of alpha? We begin by identifying the slopes of the two lines in question. Line L1 passes through points A and B, and line L2 passes through points A and C. For line L1, using points A and B, the slope comes out to be 2. For line L2, using points A and C, the slope turns out to be -4/3. With both slopes in hand, we apply the formula for the angle between two lines. This formula only requires us to know the slopes of the two lines. Plugging in the values 2 and -4/3, we simplify the expression and find that the tangent of the angle between the two lines is 2. Now we can move on to the perpendicular distance from point B to line L2. To do that, we first need the equation of line L2 in general form. We use point-slope form with point A and the slope of line L2, then rearrange the equation into standard form. The resulting equation is 3y plus 4x minus 5 equals 0. With this equation, we now use the point-to-line distance formula. It involves taking the absolute value of the linear expression evaluated at point B divided by the square root of the sum of the squares of the coefficients of x and y. After evaluating the expression with point B, we find that the perpendicular distance is 6. Finally, we multiply the distance, which is 6, by the tangent of the angle, which is 2. That gives us a final value of 12. So the correct answer is choice D. And that concludes our practice questions for Unit 1. In the next lecture, we will continue with mathematics and cover topics under the scope of algebra and linear algebra. Again, if you want more example questions for mathematics or complete FE practice tests, visit the link in the description or on screen. Thanks for watching.